Another important aspect of the psychology of problem solving is expertise. See, when you're an expert and you know a lot about a particular topic or a particular skill, as a consequence, you can organize knowledge differently than novices. And indeed, there's a lot of research to support the view that experts possess more knowledge, obviously, about a certain field, and so they organize knowledge differently than novices. And as a consequence, they tend to notice features and patterns and extract features and patterns from some problem that novices might not. And in fact, as a consequence, their expertise really affects the way in which they perceive and the way in which they represent information in their environment that is relevant to a certain problem that they have expertise on. On the other hand, the novices don't see, because they don't have all this information, all this experience with some particular topic or some particular skill, they literally process and perceive information differently. Let me just give you a couple examples of this. You'll recall from our memory chapter that Chase and Simon had tested the memory for chess pieces on a board in both experts and novices. And you'll probably remember that when the pieces were just randomly placed on the board, both experts and novices tended to perform just about the same. However, when the pieces were placed in a meaningful configuration, because the layout was actually the layout obtained from an actual game, suddenly experts could recall many, many more pieces than could novices. And see, the reason, as you remember, is not that experts are any more intelligent or have better memory than novices. It's just that because the positions were meaningful, experts, thanks to their knowledge of chess, they could actually chunk multiple pieces in meaningful units, with each unit being some kind of configuration, a queen's gambit or something of that sort. As soon as you remember the name of the configuration, let's say a queen's gambit, then you already know that entails a number of pieces that are in a certain relative position to each other. And so just by remembering one thing, the name of the configuration, you can actually remember multiple pieces. In other words, you can chunk pieces together. And this, thanks to their expertise in the field, thanks to their ability to give meaning to a configuration of multiple pieces together, led experts to outperform novices in terms of recollection for pieces on a chessboard. So this is already one example in which expertise helps us process differently information compared to somebody who does not have that expertise. A second example of this, and we've touched this topic earlier on in this particular lecture, we discussed the fact that irrelevant information can often hamper our ability to resolve problems. Now, Heather Sheridan and Ringgold in 2014 looked at the role of expertise in ignoring irrelevant information. So they also looked at chess experts and novices, and what they did is they gave them a configuration, such as the one that you see here, and the task was to select the best next move for the white player. And now what they did is, while participants were trying to find the next best move, they followed the positioning of their eyes. So this is called an eye tracking experiment. Typically, participants start by staring at the middle square, and then from there, their eyes kind of move around. And in this experiment, they were tracking where the eyes were going. Now, here's what's so interesting about this experiment. If you look at how much time, so imagine you're there, you're kind of moving your eyes, and if you look at how much time people spend in different areas at the very first go around, how much time they spend in different area of the chessboard, it turns out that novices spend just as much time looking at relevant parts of the board versus irrelevant parts of the board, meaning parts of the board that are particularly important for the next move versus parts of the board that might not be as important to the next move. And you can see this here with the irrelevant pieces commanding at the very beginning a glance just as long as relevant parts of the board. Now, what's interesting is that if instead you look at experts, well, they spend much more time, even at the first pass, the very first time you look through the board, experts are much faster at detecting that something is irrelevant, and therefore they move on straight away to something that is relevant and then spend comparatively much more time on relevant areas of the board versus irrelevant areas of the board. Overall, if you look at the total time that participants spent looking at the board, looking at the relevant and irrelevant areas of the board, it is true that both groups did spend more time on the relevant in orange compared to the irrelevant in blue. But it remains the case that overall, the experts spent much less time, were distracted far less than non-experts by irrelevant information. And see, this really demonstrates that experts have a domain-related perceptual processing advantage. To an expert, the first time you look at something and you're processing it the first time, you already have a perceptual advantage in how you're processing this information compared to somebody who does not have expertise in this particular topic. So even just the initial perception of the problem is already different. If you have, and is in fact is sort of enhanced or is sort of already helped out by the fact that you have expertise in a certain domain. Finally, there also is evidence to suggest that experts tend to spend much more time analyzing a problem and in a sense representing the problem compared to novices who instead spend more time on trying to find the solution. And so generally, experts spend more time trying to match a specific problem, so a specific game that they're playing, to previous games they've already encountered. So this means that they try to categorize problems based on principles that the current problem have in common with prior problems. In other words, they spend time doing transfer. Whereas, of course, novices do not have for all these prior games to pull from. So experts really use what they already know based on their expertise in order to plan the steps to take to solve the problem. Furthermore, as you become an expert on a particular topic, the performance aspect of it becomes entirely automatic. So you can spend much more time setting up the problem, because then the performance of the solution becomes much more automatized. Novices, on the other hand, tend to be much more conscious of the steps that they take for trying to reach a solution, which obviously adds cognitive load to the task. Now, one important aspect of this, however, is that transfer, as we said earlier, well, transfer and sort of prior knowledge and mental sets, they can both play in your favor, and that is what we focused so far in terms of what we focused on so far in terms of expertise, but it could also play against you. And one good example is that if a problem requires you to really think outside the proverbial box, as we say, novices often have an advantage. And that is because experts tend to have all this background, all this baggage with games they've already played in the context of chess, for example. And so they have all this library in their mind of things that can happen and all these established strategies that they can use to solve a problem. Whereas a novice doesn't have all these mental sets, doesn't have all this experience. And so in a sense, they can have a certain ingenuity that comes with the naivete on this particular topic. So also expertise can actually cut both ways.